Hello fantastic people, I hope you are doing great. If you are as lazy as I am, you probably hate placing assets by hand. So imagine that you have a simple 3D game like I have over here and you want to populate this area with trees. So what you would have to do is literally drag and drop every single tree. And then obviously if you want to add there some rotation, you would have to add the rotation and maybe even change a little bit the scale. So this quickly can become very tedious. So what we'll be creating today is this small editor window called Prefab Spawner, which will allow you to very quickly spawn random trees based on the settings that we provide over there. Of course, it can spawn not only trees. So for example, here I have a plank, so I can, for example, select that, align it to normal, and for example, that's a big plank. Yes, so something off with my scale of the model, but I think you get the idea. So let's get started. So our editor window will be created using UI Toolkit, and you may be wondering why. The answer is pretty simple. So it turns out Unity recommends it as the tool for developing anything related to UI. And I think this reason is good enough for us to start learning more about it, because it means they will work on improving it in the future, adding functionalities to it, and so on, so on. In order to create our custom editor window, we'll need two things. First one, the UXML file, which, if you are familiar with web technologies, is something like HTML. So basically it stores all the structure of the page, in our case of the window. So basically the positions of different inputs, their order, their names, and this type of stuff. Then there is a second thing, which is the C# script, which is responsible for handling all the behavior. So for example, if we enter something to our input, what should happen with this information? Or when we press a button, what should happen then? So I think at this moment we are ready to actually get started. Okay, so in order to create new UXML file, you go to Window, UI Toolkit, and then UI Builder. This new beautiful window will show up, and I know it looks slightly different to Unity, but actually it is pretty similar in terms of functionality. So first of all, over here, this is the working area. So basically this is where our elements will go. You will be able to see here all the inputs and all the stuff that we place. You can move around by holding the mouse wheel, and you can also zoom in and zoom out using as well mouse wheel. So this is pretty convenient. Then over here you see we have the size settings. In general, the width and height doesn't matter that much for inspector window or like editor windows. But for example, if you want to create UI for your game, you may want to check this match game view checkbox, which will basically make the canvas much bigger. Then besides those things over here, you have first the style sheets. So basically you are able to use something like CSS. Again, if you are familiar with web technologies, it's basically a technology that allows you to style different components. So basically, if we enter a button, we don't like how it looks like. Obviously, we can change all the properties on the right? So we can change the, I don't know, this is actually bad example. So let me, for example, select the color, right? So we want to make it red. We've done it using property, but we can also create classes and assign them to objects using the Unity style sheets. So this is a pretty convenient way of working with look and feel of your UI, and basically this will allow you to create reusable styles. So we'll go to that sooner or later, but this will not be part of this tutorial. Then we have hierarchy, and that's basically where we see all the objects, all the components that we place. So you see we can enter one inside the other and this type of stuff. So this is where you see that, and obviously the component library. Now, those are game specific. So if you would like to create editor window or inspector, you will have some extra options if you click on the canvas and select the editor extension authoring. Both, and suddenly we have much more options available for us. Okay, the first thing I'm adding is the visual element. in general, all the components in the library are extending the visual element. So they share some functionality, they share some stylings, and so on and so on. Now, why I do that? That's basically a way of grouping components together. So if I decide in the future that, for example, I would like to hide a section when checkbox is checked or something like that, I can easily do that because I have them. I don't have to basically select one after the other and hide them. I can hide all the like a single visual element with all its children. So that will be the main visual element. Inside of it, I will have a input for the layer mask. Be careful because next to it there's a layer input, which is not the one that you want. So I put here the layer mask. You see inside it's inside the visual element now. And what I want to do, I want to give it a name, and this is very important. Be careful what you type, because unfortunately we'll be binding them together inside the script using this name. So this is pretty error prone because basically if you make a typo here or in the script, this will cause problems. So you will literally have a null pointer exception there. So this will be the layer input, and for the label, let's just keep layer. Then under it, let's add another input, this time for the object. So this will be our input for the prefab. So let's give it a name and label prefab. And now I don't like how clumped together those elements are. So what we can do, we can take the visual element, so we can click on it over here, and then in the margin and padding section, we can increase the padding. And now suddenly they are a little bit further from the edges of the window. So in case you are not aware, there is margin and there is padding. Padding is inside the component, margin is outside. So this will be very well visible, for example, when we have a button. Let me just quickly find the button somewhere here, over here. So we have a button, and for example, you may want to have some extra space above and below the text. So you would do that using padding. So if I increase the padding, you see the space is inside the component. But you can also change the margin, which will basically add space outside the component. So as simple as that. Deleted. So we have layer and prefab, and now we can put another visual element over here, and let's maybe even give the name. So the first one will be the general settings. Then over here we'll have the prefab, or maybe instantiation settings. And inside of it, we can first add a label. So first we have a label. Let's make it scale, or maybe first rotation. And then you see we have some extra options over here. So we can open the text, we can center it. Then we can, for example, make it bold. And under it, let's add some inputs. So for the rotation, we'll want different rotation in all the axes, so we can put there two vector-free inputs. So for the minimum value and for the maximum value. So first and the second one, I failed to put it in the right place. Awesome. And now name, mean rotation, then max rotation, and also just to let you know, over here you have default values, so you could place something and it will be basically starting with this value. Actually, I think for No, let's do not give it any default value. Also, I forgot about one thing. So in order to accept only the game objects over here, we can select the type. This is a little bit tricky because if you try to write game object here, it will not work. If you try to write here prefab, it will not work. And that is because it requires the assembly name. So what you have to do, you have to write Unity and then game object. Uh-oh. Let me think. Unity engine probably. Yes, you see. So it's not the best thing, but it gets the job done. So at this moment you will see here a new texture, but as soon as we now, for example, save the file, so you can go to File, Save. Let's go to editor window. I already have the Prefab Spawner, so let me call it just maybe Spawner. And you see suddenly it refreshed and everything looks as expected. Now over here we also see that those components are pretty close to edges. So also for this one, let's open this one and select padding 10. I think we put there a little bit less for this one, right? Yes, we give it 5, so let's change it to 5. Awesome, so we have the inputs for rotation, and now let's do a similar thing for the scale. Okay, so first label over here, then let's make it bold and change it to scale. Then we want it centered, beautiful. I think it's not inside it over here, beautiful. Now we want to give it a little bit of extra margin. I think 5 will do. How does it look? Yes, 5 over here, 5 over here, awesome. And then to float inputs, and that's because we want uniform scale, so we don't want to control it per axis, we want it all together. So let's name it mean scale, label mean scale, and maybe default value 0.7, and over here max scale, and then let's give it 1. Awesome. And then one extra visual element for the toggles. So again, we want padding 5 and then 2 toggles. So first one and then second one. Are they inside? No. So let's grab them and move them over here. Awesome. Small tip. So sometimes you may not want the checkbox to be over here, but on the left. Then what you can do, you can remove the label and put text inside instead. So what will happen, you see the checkbox will be on the left. So that's a small trick. Now what I wanted to do, okay. This one will be active, so if we are using the spawner or not, and the second one will be align to normals. I forgot to give them names, so align to normals, or maybe normal. Awesome, and over here active, name also active. And I think that will be it. Yes, that will be it. Align to normal, in case you are wondering what it will do. Basically, sometimes you have items that are like trees, so it doesn't matter on which what is the normal of the surface that they are placed. You want to have them facing upwards, but sometimes you will have objects that you want to lie on the surface. So for example, I had a slope inside my level and I would like to put a plank on the slope. So then we'll use align to normal to basically just project the normal to the rotation of the object. Okay, so that's it. Over here, let's save it and let's move to our script. Okay, so I'm closing this window. We won't need it anymore. In my assets, you see I have a editor folder. This is pretty important in general. Whenever you do some editor development, you should keep all the files in the editor folder, because basically what will happen, Unity looks inside of it for any things like property drawers, custom inspectors, and all this type of stuff. So I think there are certain things which do not have to be in editor folder, but I'm now not sure. So in general, whenever I do the any development related to editor, I always put everything inside the folder. So now I will create a new script, which I will call Spawner. Let's open it. And the first thing I will want to do is basically I would like have the option to open the window. So first of all, let's move it to the editor namespace. So that's the first thing. And then let's change the extension from, so basically I want the spawner to extend not mono behavior, but the editor window. That's what will give me some extra functionality. Now I need to import the Unity editor namespace. So let's do that. Awesome. And now somehow we have to reference the UXML file we created. There are different ways to do that. I've seen a lot of people using the load from path or something like that method, but I really hate it, because if you hard code path in your code, basically whenever it changes you have to adjust the script, and this is quite problematic. So what I prefer to do instead, I prefer to add serialized field to store the visual asset tree. So that's basically, the visual tree asset. This is basically the UXML file. And let's call it tree. That will do it. We'll set it in the inspector in a second. So now let's create a method that will allow us to open the window. Now this method doesn't have to be named any specific way. What's important, it has to be static. So I will call it show editor. Okay, and now it has to have the attribute menu item. Let's give it the path tools and a spawner, because again I already have prefab spawner, so we want to have spawner instead. And basically what we have to do inside, we have to create a new window, so, or rather get the window. So let's call it window, get window, and now we want to say what type of the window we want to receive. So in our case it will be spawner. And now, sorry, that should be tools. And now we can also set the title of the window. So window title content equals new GUI content, and let's type here spawner. Awesome. And this is enough to show empty window. So let's have a look if it works. So I'm going to tools. You see I have now this option spawner. I click it and I have beautiful empty window. Awesome. Let's close it, and now let's load there our asset or our UXML file. So we go over here. Okay, so the method that we'll be using is called create GUI. So it's basically even function like the ones that we have in game objects. So in the mono behaviors. So update, on enable, and so on and so on. So the editor window has one of those called create GUI. In this one, what we can simply do, we can add the tree asset to our root visual element. So in order to do that, we access the root visual element. We have access to that because we extend the editor window, so we don't have to do anything special here. You just have access to that. And then no, the other way around. So what we have to do, we have to say that we want to clone everything that is inside of the tree. So we do tree.clone tree, and we have to specify where we want to add it. So in our case, it will be root visual element. So that's really it. So this should be enough to see the window we created. Now we only have to assign to our spawner script. Over here you see we have this tree property, so you can drag and drop there the UXML file. And now if we go to Tools, Spawner, we already see our beautiful window. Now let's add there some functionality. Okay, so now because we want to use the values from the window, from the inputs there, we need to reference them in our script. For that, we basically create a variable for each of those inputs. So for example, we have active toggle. We had another toggle for the align to normal. And then we had, for example, the object field, which would be private object field, object input, or maybe let's call it prefab input. And you see it actually imported another namespace, right? So it's using the Unity editor UI element. So you see we have two groups of UI elements. When we checked the checkbox editor authoring, if you remember at the beginning, basically this gave us access to those extra inputs or components. So so to don't waste your time, I'm going to copy and paste all of them. Besides the object field over here, I will explain why in a second I don't have the object field over here. I basically want to show you two ways of grabbing the values and working with them. So now you see I have those ones over here. I go to my create UI and over here I will be basically assigning those different types of elements. So for the first toggle, we have active toggle. What I need to do, I know I want to get it from the root visual element, right? So I want the active toggle to be from root visual element. I want to query, so you use the letter Q for that. And then over here, you provide the type. So it will be toggle. In general, when you have just one element of that type, this would be enough, but I never recommend using only the type, because if you ever add extra toggle, you suddenly you have a problem, because basically you may not get the one that you need, and so on. So basically I always advise to put here also the name, even if you have just one element of a given type. So in our case it was active. And we repeat the action for all of those fields. Once again, I'm just going to copy paste it from my script. So over here, so you see it's exactly the same. So for toggles, I have toggle and their name. For layer mask field, I have layer mask field. So nothing special over here. And this is the first way of working with those inputs. So basically what we would do whenever we need them, whenever we need the values, we would simply do, for example, max scale input, and we'll be doing that in a second, and value. And we have the value from the input. It throws an error because I don't assign it basically anywhere. So you see that. But there is also another way of grabbing the values, and that's the event-based way. So for example, we have the object, not over here, but over here we can grab also the object input, right? So we have the prefab input. Let's grab it from the root visual element, then query it. It will be the object field, and its name was prefab. Now we can, it has some events. So for example, we can write prefab input and now look for anything related to change, and there is, you see, register value changed callback. So basically this expects us to provide a delegate which will help us handling the value. So basically it will say what should happen when the value is changed. So we have the new value, or the event for the so let's maybe call it event, and now we can write the action over here. So for example, let's say we want to create a private game object variable called prefab, and we want to assign it over here. So prefab equals event new value as game object. And this way we'll basically get the new value from this specific input. So it's really up to you which way you prefer. Both are, I think, equally convenient. It's just for, if you prefer this way, you would have to, instead of creating fields for the inputs, you would have to rather create values, variables for underlying values, right? So for toggles it would be booleans, for layer input it would be layer mask, and so on, so on. So let's move that to a separate method, because I think this looks ugly. So let's create a method called init fields. Put them over here, and let's call that from created GUI. Beautiful. And now let's handle our spawning objects. So for that, we'll have to register, we will have to be responding to the scene events, because we want to get the mouse position, we want to get the click information, and so on. So for that, on enable, we want subscribe to the scene view during SceneGui, and we want to create our own method, which will be called on SceneGui. Beautiful. So now let's generate it. You see it takes as a parameter the scene view, because this will give us some extra information if we ever need that. And here we are ready to actually handle the events. First of all, if there is if the component is not active, so if our toggle is not checked, we basically want to do nothing. So if the active toggle value, and we reverse it, so if it's false, then return, simply return. Awesome. However, if it is active, we want to check what is the current event, and we can just create a shorter variable for it, because there is something called event current. So this stores information about the current event. This way we can have it a little bit shorter. So here we have the information about event, and now we want to check if the event was the mouse clicked. For that we have to do two things. If first we want to check if the type of the event was event type mouse down, and then missed that, and then we want to check if the button pressed was 0, which is the left one. And if you don't do the first time, I noticed that this one is kind of basically happening all the time. So this event is triggered all the time, even when I do not press the button. So this is weird. Probably there is reason behind that, which I simply don't understand. Now, I like to have everything nicely organized. I don't like if statements like that, because those are really error prone. So what I created for myself is this simple extension method. So it's basically, if you want to learn about extension methods, there's tutorial. Basically I have extension method which is called isLeft mouse button down, which basically wraps around this ugly notation and allows me to do this magic. Look at that. Event is left mouse button down. Poof! Done. So I have this over here. And now if the button was pressed, we maybe first want to log it. So just let's double check if that works. So left button clicked. And now let's go to our Unity. We have our spawner, and let's open the editor window. Doesn't happen anything
is not happening when the active checkbox is not checked. When we check it, yay, we have left button clicked. So everything works as expected. Okay, so let's the fun begin. Now, once we click the left mouse button, what we want to do, we want to shoot a ray from the camera towards the point where we clicked and get the position if we manage to hit the object in the layer that we are interested. So for that, let me think. First we have to use, first we need to get the actual ray. So for that we can use the handle utility, which is a special class that has a lot of functionality, like helper functionality related to working with handles in Unity. Handles is, handles are like gizmos on steroids. So basically they can do everything. And one day I will make a video about them too, because this is pretty awesome subject. So handle utility, and then we want the GUI point to world ray, and then we want to provide it the event mouse position. This gives us the ray that we talked about. Now we need to know if it hits something, right? So for that we can use physics and raycast. So for that we provide the ray we want to use. This will give us starting position and the direction. Then we want to receive back information if we hit or not, and some extra details. Then we want to give it infinite length, so we want it to shoot as far as possible. Yes, and then we probably want to give it also the layer mask, and we know that because we have our beautiful input. So layer input and then value. So that gives us the raycast hit, and now what we can do, we can simply check if the raycast hit has any collider. If it has, it means it hit the target. From this raycast hit, we are able to get the position where we want to spawn the object. Now let's spawn the object. So for that we can make a method which will return the game object. And now let's call it create prefab. That will accept the vector-free position because we want to know where to place the object. And now we are going to create it. So first we'll be using the prefab utility. And thank you, Vsat, for this amazing tip, because I didn't know there is a way to spawn prefabs properly. So basically, normally I would use instantiate, which would just create a regular game object, and now the prefab utility allows me to create a nicely wrapped prefab, which is actually the instance of the prefab, so very nice thing. And over here we want to instantiate prefab and want to provide the object. We know this one because, as you remember probably, we had the prefab input and we registered, like we listen for the change, and whenever the value changes there, we get the new prefab. So we have that, we create the object, and now we want to set its position. So object, it has to be as game object. Of course it has to be game object. So now transform, and now we want to set its position to the given position. Awesome. So we have that raycast hit point, and that is the first. Why you don't like it? Do I? Oh, okay, here, the scene view. Awesome. So we have the object created. Now we should rotate it probably, right? So for that, let's create another method. We forgot to return here object. Awesome. And now private void apply random rotation. For that, we need to receive the game object that we want to rotate. So game object, and inside our method first, we want to know what is the minimum rotation, and well, we don't have field, so we need to create that, and we can get that information from minimum rotation input value. Then we also want to know what is the maximum rotation. and we can get that from maximum rotation input value. Awesome. So we have those two, and now we also want to know if we should be aligning our object to the normals or not, to the normal of the surface that we clicked. So var align to normal, and we can get that from the align to normal toggle value. So we have all the information we need. Now we have to handle that. Actually, I just realized that beside the object, we'll also need the information about the normal. So in order to get that, what I'm going to do, I'm going to create here a vector-free variable called normal. And when we call the apply random rotation, we're going to pass the object and the raycast hit normal. Awesome. Beautiful. Okay, so now we need to check if our align to normal toggle was checked. And if it was checked, then what we do, we simply set the object's rotation, transform rotation to quaternion from to rotation. So this will allow us to convert the normal, which is a vector, to quaternion. And the first argument will be the from direction, which is basically we want to look where is the up, right? So we have our model and we want to rotate up the way that the normal of the surface is. So basically for that we do vector free up, and then we want to move it to the normal position. As simple as that. So this will allow us to rotate the prefab. And now we need, on top of that, add the random rotation. So for that we can do object, transform, rotation, quaternion, and from Euler. So Euler angles are those convenient angles that we set in the inspector, so 0 to 360. And over here we can do object, transform, let's maybe first store that. So var rotation in Euler, and we can do object, transform, rotation, and Euler angles. So here we have the information about existing rotation, right? So in case we changed the object to be aligned with normal, now it will be not 0, 0, 0. So rotation in Euler X plus random range. And now very important, you have to be careful which random you use, because we are not interested in the random from the system namespace, but rather random from the Unity namespace. So new Unity engine, range, and now minimum rotation X, maximum rotation X. So this will give us a value between the values in first vector and the second one. So that's first one, second one, and third one. So for that one we want Y, 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 Z, Z, Z. Awesome. So this should do it. Let me check if we call it, and let's have a look if it works as expected. So over here we have our spawner. Let's set the layer to ground, and let's select the tree prefab. Okay, so basically there is one interesting thing. Let's go to the UI Toolkit for a second. So you see on the game object, on the object field, we have this checkbox allows scene objects. So this have to be unchecked if you don't want to enter there the objects that are in the scene window. And we don't want to do that. We want only prefabs. So I'm saving that. And now let me just close it and reopen it. So tools, spawner, and now ground, and you see over here I have only the objects from the basically project window. So over here let's put -30 30 just to see if everything works this way, it will be very visual. So that, then we want it active, and let's click, yay, it works. So awesome. Now let's check. So if I click over here, you see it's still kind of facing up. If I go and click the align to normal, now you see this is much more turned to side. Over here you see it's going to be beautiful. So I'm sure you can think of many ways to actually use that. But now we have a small problem. We cannot press Ctrl Z, and I wasn't aware of that too. So once again, thank you Vsaught for this amazing tip. So well, I created so many of them, and of course I'm creating because it's still active. So whenever I click, that was fun. So in order to allow us undoing of this action, we need to go back to our script, and over here, after we spawn the object, we have the undo class, where we basically call the method register create object undo. And now we have to provide the object that was created, and we also have to provide small description. So prefab spawned. And now if we go to Unity and spawn something, we can press Ctrl Z to undo that. Awesome. So once again, thank you so much, Vsaught. This is great tip. And now the last thing that is left is applying the random scale. So let's open our script. Let's create another method and call it private void apply random scale. For that we also need the game object. And let's scroll down a little bit, and now we need to get the values, right, of the minimum and maximum allowed scale. So for that we can do min scale, and once again get the values from the inputs value. Awesome. Var max scale, max rotation, max scale input value, and now we simply apply that rotation. So what we can do here, we simply do object transform scale, local scale, and now we do vector 3 1. So this will give us vector which is 1 1 1, and now if we multiply it by random range min scale max scale, so this will give us a random number, and the vector 1 multiplied by this number will basically shrink or grow to that particular size. So this is pretty convenient. It's much easier and shorter to write this than creating a variable to store that and creating new vector 3 and providing it 3 times for each axis. So we have that. Let's call it over here object. And everyone, I think we are done. Let's test it. So we select ground, we select the tree. Let's leave the rotation for now, and let's create a different size of tree. So if we click now, nothing is happening. So yep, you see that's okay because we don't have the active checked. Now we check the active and we start creating different size of trees. Yay! I cannot wait to see what great editor windows you will create. So if you create anything interesting, please let me know. You can do it here in the comments, or you can contact me on our Discord server. The link will be in the description and probably also in the pinned comment. Have a fantastic day. Love you and bye bye.